Hello, amazing hackers. Hope you're all doing well today. Welcome to another video. So in this video, I want to talk a little bit about WAFs or web application firewalls. You've probably all encountered them and they're annoying as can be for us hackers. So let's talk a little bit about them, shall we? So let's just pretend that this is us. This is just the actor that we're talking about. And let's pretend that we try and reach a specific website over here. So this is the actor that we have, and we have a website. Now this is going to be important later on. There we go. And our website, I'm typing here website, of course. Now, as we go on, our actor is going to want to access this website. That's normally going to try and make a specific GET request. So let's type that out. He's going to make a GET request to / let's call it index.php. All right, so that GET request needs to be done. He's going to try and do it. Let's draw a stamp. Going to try and do it, but he's going to encounter some filters along the way because you, as the owner of this website, of course, don't want any input to come to your website. You want it to be clean, you want it to be sane. You don't want any crap on your website that might break it, of course. So what are your options there? You have a couple of options as a website owner. You can basically install a web application firewall. Now, it's really important to know that if you do this, you still need a regular firewall because we're talking about web application firewalls. They will only filter web application traffic. Really important to know. So first of all, what we're going to do is we're going to enter a pre-processor phase. Now, let's take a little bit of a stamp. There we go. And this pre-processor phase is basically going to ask, so this is the preprocessor that we have here, preprocessor. There we go. And the preprocessor is going to try and grab all of this data. It's going to make it uniform. It's going to tidy it up. And it's going to try and remove all of the outliers. Now, this function is not as important. We move on to the next one. Then we go to the normalization function. So in the normalization function, we have a couple of other things that are going to happen. This is basically where all of your things like your Unicode and all of that stuff get decoded. So normalization. Let's say I have a base 64 value in my request. I need to decode that and I need to check it as well. I cannot just pass it on as a value of base 64. We'll get more into that later, but it's really important that I filter this out properly. So that's why my normalization is here. It's going to try to decode Unicode, UTF, anything base 64, hex code, anything it encounters, it's going to try and normalize that stuff. So then when that has happened, you're only left with sane HTTP and HTTPS requests that don't have any UTF code in them, that don't have any base 64 code in them. So then we move on to the next step. And this is why we've all been doing this. As we go on, we come on to the last one, and that's the input validation step. Now, this is one of the most important steps because this step is going to determine if your text is going to be allowed into the website or not. Here we have the input validation step. Now, in this input validation step, everything is going to get checked. Simple as that. But of course, this is going to take a lot of CPU power because if you're checking something, you're actually opening it, you're reading it, you're seeing it, you're checking it for errors, and only then are you passing it. This checking often works on a blacklist basis. What does a blacklist basis mean? It basically means that we have a list of specific words, like this one here. We have word A, we have word B, we have a word C, and we have word D. If any of these words are in the request, then the request is getting blocked off. So that's basically a blacklist. If any of the words on the list is in the request, it's getting blocked off. That's not good, of course, because that takes a lot of power. If you have a giant list, that's going to take a lot of power. And if you think about the possible web application attacks, then you know that you're going to have a giant list because we're not just talking about cross-site scripting here. This blacklist needs to contain cross-site scripting patterns. It needs to contain SQL injection patterns, remote file execution, local file execution, XXC. It needs to be able to recognize all of these different patterns And that's why input validation is going to take a long time. So the normalization and the pre-processing happens, so it's going to take a little bit less time. But then after that, we can do our input validation. Now on to the next part. Let me just quickly grab that here. There we go. So we can move on. Yep. Sorry about the small interruption here. But then we basically move on to, let me just pause it. All right, amazing hackers. So now that you know how this input validation works, how these web application firewalls work, we can move on to the next step. Let's say you're an attacker and you're trying to get around all of this. How would you go about this? Well, actually, there are a couple of things that you can try, because this is basically the principle of a web application firewall, but there's so many complexities and there's so many ways of implementing this that it's going to be impossible that two vendors have the exact same solution. Every vendor is going to have their own strengths and weaknesses. And that's going to be something good for us, because some vendors will spend a lot of money getting very secure applications, while other vendors might only have the input validation because they don't want to spend as much money and they just want to make a product that works. So they bring out this input validation product. It will cost a lot less, but it's going to be a lot slower. It's going to skip a lot of validations and all of that stuff. So there are going to be differences in these different web application firewalls. That's very important that you know that. Some of them won't have this preprocessor, some of them won't have the normalization steps, and we can fool those steps, by the way. That's also what we want to do. Let's say, for example, that the normalization step is going to be missing from our story here. Well, in that case, what you can do is, let's say we have an attack vector. So let's create a quick attack vector here. Let's say we are making a request to get index to search.php. Let's make it to search.php. Then a question mark, of course, for a query. And then we're going to do let's insert a broken image, shall we? So that would be image source equals x on error equals alert. Very basic. What am I doing here? On error equals alert. So this is a very, very basic attack vector that we have here. Of course, you need to close it down as well. Let's say I sent this over to the server. The preprocessor is still there. The input validation is still there. So this is going to fail the input validation. It's as simple as that. Input validation is still there. It's going to be looking, oh, this contains on error, on alert. It contains a JavaScript handler. It contains a JavaScript function. That's not good input. It's not sane. I'm not going to show it. So, okay, then what can we do about this? You might be wondering. Well, let's start with the first one. Normalization is gone. In this case, we can base 64 encode our values. So if we do this, we can also do I'm just going to do the query part now, by the way. We can also do query equals, and then we can open our tags again. And we can make it a data tag. So data, and then we can say text/HTML, and then we can say base 64 for base 64 encoded. So what we can do then is base 64 or encode our payload here, and then we can paste it here. Of course, we need to put a comma behind this as well. So let's quickly do that. Can we still do that? Base 64 comma. There we go. Ooh, that's an M. So any payload that you paste in here, base 64 encoded, is going to come into this data field. And then when we pass the preprocessor, because the preprocessor isn't going to check for this, it will continue on to the input validation. The input validation will see a bunch of base 64 text, and that base 64 text will be useless to the input validation. It will be like, okay, this is nothing, let's let it through. So then it'll say, oh, this input is okay. And then it'll let it through to the website. And of course, the website will start decoding this and our alert might still pop. That's what we want to achieve with this kind of attack. Now, there are other scenarios as well, of course. This is just a very simple scenario, but there are some language-specific tricks that you can use as well. For example, I'm going to just take the basic query again that we had before. So let's see, query equals. And then let's say there's a local file inclusion on this one, or even a remote code execution. Let's make it real cool. Let's say there's a remote code execution on this parameter. What can we do? Let's think about this. Okay, let's cut the etc password file. So let's do a cat of the /etc/password file. Now in this case, I'm quickly going to draw back our normalization here because that's something that we have back right now. So our normalization is back again. There we go. Normalization. We have it back. And in this case, we can try a couple of things here. Because, for example, if we're talking about PHP, what PHP will do is it will automatically remove any spaces that we have in our URL, and it will replace them with an underscore. So in that case, what we can do is we can try to, let's make another query parameter here. We can do a cat %20, for example, C %20, and then a T, and then /etc/password. If our cat was our filtered word. So if we do a remote code execution and cat seems to be our filtered word, then we might be able, if it's PHP, we might be able to get around it by adding this %20 in here. What this %20 will translate to is a space, and PHP will replace that space. So what that means is that this cat command will still be executed, and we can paste this anywhere. Let's say the etc directory is forbidden. Let's say the password directory is forbidden. So as you can see, we can paste this anywhere, basically. So that's very important. And I think I lost my whiteboard. There we go. Back to it. So for these, it's really, really important that you know what technology you're hacking. Am I hacking PHP? Am I hacking ASP? Because ASPX, what they will do is, I'm going to make another query. What ASPX will do is, if I do cat, and if this is a filtered word, what I can do is I can add a % in here, just a simple %. What this % will do is it will, in ASPX, what it's going to do is it's going to remove it, just remove it if there are no numbers behind it. There have to be 2 numbers or I think hexadecimal values. So basically there have to be, I think, hexadecimal values behind this. And if they're not, ASPX is going to filter this. So if we execute our command like this, and cat is the filtered word, then it's still going to get through because ASPX is going to filter this, but it's already too late because then our input is already at the website. What you have to know is that all of this stuff in the web application firewall is basically a layer before our website. This is just like another server, like another firewall, and it's going to capture our requests before they reach the website, and it's going to try to filter anything that's not allowed. Now I'm talking about this % here. That one is a pretty interesting one, but those are bound to their technologies. This one is ASPX and this one is PHP. There are some other techniques as well. For example, you can just add spaces maybe. Let's try another one. Let's open up our image again. So we have our image that we had, but let's just add a space this time. So image source, and then we add a space equals, and then we add another space X. We do that as well for the event handler on error, and then a space, and then a space again, and then alert. So that's basically a basic, there we go. Let's close this down. That's also a way we can get around filters sometimes. What if the filter is looking for source equals, or on alert equals, or equals alert, or something like that? You never know, so it's always worth a shot. That's a really basic one. We can also try things like if we have this one again, let's make another text here. Q equals cat. Let's make it just an ls. An ls is really easy to type. So you have an ls command here. What we can also do is just add a / in here, because the moment we add a / in here, what Linux or Bash, I should say, what Bash is going to do is Bash is going to interpret this as an escape character. And since there's nothing to escape on this S, it's just going to display this S. but our filter might be looking specifically for the ls command. And if it's not exactly that ls command, some filters might get very, very confused. A little bit more about that later, because I think it's very important that you know. Now, the next trick I want to show you is you can also do some really cool stuff with things like wildcards, for example. I don't know if you know this, but you can do Q. If I want to do the ls command, I can do L and then a star and then S. Try that. Try that on your terminal right now. It will execute. That's really, really cool, really funny. I've also have this one where you can do like the, let's say you want to do cat/etc/password. It's possible. Some people want to do that. So let's go /etc/password. Now let's say you want to do this. You can also do this by putting a single quote around the W, for example. That's also going to be interpreted just as the etc password file. By the way, I'm not sure if it's password, or password, like password. You have to give it a try. I'm really sorry. I have bad memory, so I don't remember this stuff. Anyway, single quotes are also very useful in this, but also just double quotes. Let's just surround it with double quotes, you know? That's also very useful. Just don't remove it. There we go. That's also a possible way to get around one of these filters. We can also do some other things, like we can add a star character in the middle of it. That's also possible in the middle of anywhere in our command. And Linux is going to interpret that properly. It's going to run our command. We can enter 2 stars, etc. Many, many, many possibilities. Now, what I also wanted to show you is wildcards, because you've probably all been working with wildcards before, but I don't think you realize how powerful wildcards really are. This is a really, really cool trick, and I like it. So let's say we do a cat again of the /etc/password. Okay, nothing wrong here. But did you know that you can also do a cut of the etc pass and then question mark? That's interesting, because what Linux or Bash, I keep saying Linux, but I should say Bash. What Bash is going to do in this case is it's going to replace this question mark with the first thing that it finds. So it's going to look for anything that matches this pattern, etc pass, and then it's going to look if there's anything that matches the complete pattern. Like there can be one character in this location. That's what this question mark is all about. There can only be one character in that specific location. And that's very important, because if we do this slash question mark, slash, and then I think it's password PASWD. So if you enter this, you're still going to get your etc password. Unless you have a file that looks a lot like this in any location, then you're going to get that file. But it really depends on which one is found first as well. So this is a really cool trick, because if I'm not allowed to do any input, if I'm not allowed to grab the etc password file, for example, for the input validation, if the input validation says no, that's not going to happen, then I might try and catting this, and the input validation might think, oh, that is catting a bunch of question marks. It's strange, but I don't mind. It's okay. Go onto the website. And in that case, the website has a real big problem, because it's still catting the etc password file, but nobody's really sure. And if you can't do the cat, and if you cannot run any commands at all, you can still run commands. I don't know if you know this, but this is something really cool, and I love this. You can just go to let's do /user/bin, or you can just do it like this, /user/bin. And if there is a command that is only just one command strong, if there's only just one command of it, you can just try and do it with the question marks that we just learned. You can just try and autofill this with, like, if it's like the ls command, this is not going to work, because this is going to grab the lp command, what I'm doing right now. So let's say you're not allowed to execute anything at all on the server, because the moment you try to execute a function or anything at all, it's going to block you on the input validation stage. Well, in that case, you might be able to serve to the user bin directory, and the server might allow you. It might say, okay, you're just going through a random directory, I don't care about that. And then you might still be able to execute commands using this question mark strategy. You just have to make sure that you know what your target looks like. If he's running Linux, if he's running Ubuntu, if he's running Fedora, if he's running whatever, but you just need to know what their infrastructure looks like, what they're running at the moment. And then of course, you can try and grab data with this as well. I've been talking about commands, but you can grab data as well. It really depends on what you want. So as you can see, there are quite a few ways to get around web application firewalls. So don't be discouraged if you see one. There are more ways than I'm showing right here. I am sure of that. And there's one trick which I'm not going to tell you. I'm really sorry, but I think it's irresponsible of me because it has a zero educational value in the context of YouTube. So if you guys enjoyed this video, I would highly appreciate it if you guys gave me a thumbs up. It's been a lot of work and I love doing this. Thank you so much for watching, everybody. Uncle Red out. Peace.